Hello friends, welcome once again to n+2 online math class. In this video, we are going to prove by induction that this is divisible by 3. Somebody sent this problem in the comment box and I decided to make a video on it. Okay, now for you to prove that anything is divisible by any number or any term, you must follow three conditions must be satisfied according to the principle of mathematical induction. The first condition is that n equal to 1 must be satisfied. Then you assume that n equal to k is also true and n equal to k plus 1 is true. Okay, now for n equal to 1, it means that wherever we see n here, you plug in 1. If it gives you something that 3 can divide, it means that it is divisible by 3. So we have 5 power of 1 plus 2 into 11 to the power of 1. This is the same thing as 5 power of 1 is 5 plus 2 times 11 is 22, and that turns out to 27. And since this is 27, it is divisible by 3. Therefore, n equal to 1 is true. Then for n equal to k, we assume, so we also assume that n equal to k is also true. And for it to be true, you have that 5 to the power of k plus 2 to the into 11 to the power of k. We assume that it is true, equal to 3m or 3 whatever. So this 3m implies that this is giving us something which 3 can divide also. Now, after this, you now test for n equal to k plus 1. And if this last condition is satisfied, you conclude that the expression is divisible by 3. So before we do that, I need to clean the board so that there will be enough space for that. Remember that for n equal to k is 5 to the power of k plus 2 into 11 to the power of k equals 3m. So let's take note of this before we begin. So for n equals k plus 1, look at what we have. Anywhere you see n, you put k plus 1. So this is 5 to the power of k plus 1 plus 2 into 11 to the power of k plus 1. The idea is to see if we can get this 5 to the power of k plus 2 into 11 power of k in this particular expression so that we can plug in 3m there to represent it. But if you take a look here, it is almost impossible to generate this. Therefore, from this one, let's say I'm calling it equation 1. Let us make 5 to the power of k subject of the formula. But before that, let us simplify this using our knowledge of indices. This can be seen as 5 to the power of k times 5 to the power of 1, because multiplication implies addition from indices law, plus 2 into 11 to the power of k times 11 power of 1. From the laws of indices also, addition is multiplication. Then from here, you now see that 5 to the power of k is the same thing as 3m, which is here. This plus coming over becomes minus 2 into 11 to the power of k. So I made 5 power of k here the subject of the formula. So this is now equation 2. So from here, wherever I see this 5 power of k, I will put all these things to represent it. Hence, we shall have 3m minus 2 into 11 to the power of k, representing our 5 power of k here. Remember, we'll have 5 power of 1 here, which is just 5, plus 2 into 11 to the power of k times 11. Now let this 5 open this bracket, so we shall have 5 times 3m is 15m, 5 times minus 2 is minus 10 into 11 to the power of k, plus 2, okay, without wasting time, 2 times this 11 will give us 22 times 11 to the power of k. Now let me rearrange. Let me move this minus here so that the plus comes first. So this will be 15m plus 22 times 11 to the power of k minus 10 times 11 to the power of k. That is minus 10 times 11 to the power of k. If you look up here towards the right, you see that 11 power of k is common, so you are free to factor it out. When I do that, I will have my 15m plus 11 to the power of k into, I'll be left with 22 here because dividing by 11 power of k, 22 is left. Take away, if I divide by 11 power of k here, minus 10 will be left. So we now have 15m plus 11 to the power of k times 22 minus 10 will give us 12. Then looking at this particular expression, you see that 3 can divide them. So you bring out your 3 into 15m divided by 3 is 5m plus 12 divided by 3 will give us 4. So we have 4 times 11 to the power of k. Now since 3 can be factored out from this, just like what we have here, it means that this expression is divisible by 3. Therefore, n equal to k plus 1 is also true. And since this is true, we conclude that it is divisible by 3. And these are the stages you must embark on before you say that something has been proved using the principle of mathematical induction. So thank you for viewing, and may God bless you. Do not forget to follow me on Instagram, TikTok, YouTube so that you'll be notified each time a new video is uploaded.